Okay, so about rotational symmetry in crystals. So there's there's five kinds of rotational symmetry that are allowed. The first one is one-fold rotational symmetry, which is an object that is required to like rotate a full 360 in order to restore to its original appearance and has no or like rotational symmetry. Since it repeats itself every 360 degrees, it is said to have a one-fold axis of rotational symmetry. And next we have two-fold rotation symmetry, which is if an axis appears identical after a rotation of 180 degrees, that is twice in a 360 degrees rotation, then it is said to have a two-fold rotation axis. Note that in these examples here, over here, the axis we are referring to are imaginary lines that extend towards you perpendicular to the page or blackboard or toward like the slide. A filled oval shape represents the point where the two-fold rotation axes intersect at the page. So all of these my slides are examples of these. Um, Next we have threefold rotation axis. These are objects that repeat themselves upon a rotation of 120 degrees and are said to have threefold axis of rotational symmetry because 360 divided by 3 is 120, and they will repeat three times in a 360-degree rotation. A filled triangle is used to symbolize the creation of threefold rotation axis. So right here you can see there's a triangle, and yeah, these are examples. As you can see there, if you rotate it 120, it will get the same image. Next, we have fourfold rotational axis. If an object repeats itself after 90 degrees of rotation, it will repeat four times in a 360-degree rotation, as like illustrated here, which you can see by the square that symbolizes fourfold axis of rotational symmetry. So if anywhere you rotate it 90 degrees, it will become the same image. Next, we have sixfold rotation axis. If it's rotated 60 degrees about the axis that causes the object to repeat itself, then it has sixfold axis of rotational symmetry. If a filled hexagon is used as a symbol for a sixfold rotation axis, as shown right here. And in these images, as you can see, if you fold it 6 times, it will be equal each 60 degrees rotation. Next, we are going to discuss examples of disallowed symmetry, which are some examples are the fivefold, sevenfold, and eightfold or high rotation axis that are not possible in crystals. The reason that that the external shape of the crystal is based on the geometric arrangement of atoms, and if you try to combine the fivefold, eightfold, and other like disallowed symmetry, then you cannot like um combine them fully to have, but because there's still going to be a gap. As you can see, if there's a fivefold here, fivefold here, fivefold here, fivefold here, and if we keep on adding it, there's going to be this rhombus that's missing. And here we see an eightfold symmetry, but you see there's this square part that's missing. And there we have it. Thank you.